This video will explain the entire process of producing a pre-stressed concrete unit at a pre-stressing plant, in this case, a double T. A double T is used primarily in parking structures, but can be used in virtually any type of building, including office buildings, industrial buildings, and schools, to name a few.
Double Ts are kind of a unique product with having a capability of having a very long span. When you start talking long spans, you're talking 60 feet plus, and sometimes goes as high as 120 feet.
The typical day of a pre-stressing plant usually starts very early in the morning. The product from the previous day's casting has cured by now, and the pieces need to be stripped from the form to get ready for today's casting. For any pre-stressing plant, it is very important to maintain a clean plant. Maintaining neatness is not only positive from an image standpoint, but also from a safety standpoint, since any debris that might be left over from the day before could create a tripping hazard or other safety problem. The first part of the process is setting up of the form. A thorough cleaning of the entire form is done with basic labor and appropriate cleaning equipment. Setting the side forms, or in the case of a typical double T, the forms may be fixed forms with an appropriate draft to allow for easy stripping. Once the bed is cleaned, it's ready for setting up today's cast. This particular bed is set up for 5 double Ts, each about 60 feet long. The bed has a total length of 400 feet. This is a self-stressing form, where the form itself is designed to take the total pre-stress force in compression and also to handle the eccentricity of the strands. Sometimes the producer may use a form that is set between bulkheads that are built right into the ground. The pre-stressing force is then resisted entirely by the bulkheads and their foundations. Next, the strands are placed in the form and extended from end to end. Crew members thread the strands through each of the dividers and then run them through the stressing plates at each end. The typical spacing of the strands is approximately 2 inches. This divider is a steel device that separates the individual double T units from one another. A gap of about a foot is typical between the ends of the adjacent pieces. This gap is required so the strands can be accessed and cut, and that each double T can be stripped from the forms. The next step is the tensioning of the strands. In this case, we have a strand pattern with straight strands of 6 strands in each stem, as shown here. The strands are first tensioned to about 2 to 5 kips based on the gauge pressure reading. In this case, a mark is made on the strand after the preload is applied. The strand is then tensioned to the specified level and is measured using the gauge pressure on the hydraulic pump. The QC technician then checks the elongation against the theoretical elongation. The requirement that is the force on the gauge and the elongation must match within 5%. If that tolerance is not achieved, the reason must be established and the strand may have to be detensioned and retensioned. After the strands of this double T are all stressed, the remaining embeds are set in place. These include stem reinforcing, lifting devices that will be used to strip and handle the piece, forms for blockouts in the flange, and forms for blockouts in the stems, flange reinforcing, and flange connectors or vectors along the edges. In this case, one of the double T's in the bed has typical flange connectors applied along one edge and special flat plate connectors applied along the other edge to accommodate connections across an expansion joint. The form is now ready to have concrete poured, but only after a pre-pour quality control check has been made and the QC person signs off on it. This QC check can also be done by the bed superintendent and depends on the particular plant's practices. Either way, the check is critical to ensure an end product with the highest quality.
There's all these things you look for. The mesh, you look for anything that could be touching the stems on the bottom, like wire ties that might have fell in there because that would develop some type of a rust spot. You check the length. You want to make sure that the damps are correct. Do we have the strand stripped properly? So there are a lot of critical areas that you need to verify.
Concrete is mixed at the batch plant under tightly controlled conditions. The cement is supplied using tanker trucks. Here, the cement is being blown from the tanker through piping to the cement silos. When needed, aggregates are delivered to bins in the batch plant. The aggregates are stored outside of the batch plant in separate bins. In this case, an enclosed vertical bin system is utilized. During winter, in northern climates, the aggregates must be heated to get them to flow properly through the batching system and to maintain proper concrete mix temperatures. Payloaders are used to shuffle the materials to the conveyor belt. Computers are used to proportion the materials for the desired concrete mix. Cement, sand, stone, water, and admixtures are measured according to signals from the computer. After the concrete is mixed, it is discharged into a delivery device. It's imperative that the concrete mix be delivered to the form as soon as possible. These vehicles are called tuckers, and they are used to deliver the concrete to the bed in the yard. A self-consolidating concrete is being used to cast these particular double T's. With this type of concrete, vibration is not required to consolidate the concrete. However, minor controlled vibration is used in the double T stems to help remove air from the sides of the form, reducing bug holes in the stems. There are many advantages in using this type of concrete.
We do use self-consolidating concrete for our double T's. We feel that it gives us a better finish. We feel that it's easier to place, takes less labor, less strain on the labor to place that concrete.
The QC department will make the necessary tests at this time, including a temperature check of the concrete. Since SCC is being used here, a spread test is done to check the concrete flow in lieu of a slump test. The spread is measured to assure conformance to the planned spread. The edges of the circle of concrete are also inspected to check for segregation. The appearance is translated to a visual stability index number. There is a check for air content. Cylinders are filled and will be used later for strength tests of the cured concrete. Back at the bed, the concrete placement continues. A vibrating screed is used to level the surface evenly. A bull float is used to finish the surface. An evaporation-reducing spray is also being applied to the surface to minimize the potential for plastic shrinkage cracking. The final finish will vary depending on the use of the double T. If a cast-in-place topping is necessary, the surface will be made very rough so that a good bond will be achieved. If it is a roof, the finish will be relatively smooth but not necessarily perfect. In this case, the surface is broomed as these double T's are being used in a parking structure. Different patterns can be applied depending on the needs of the project. The bed is now in its curing stage. Sometimes, particularly in cold climates, the double T may be covered with tarps. In other areas, they may be open. Accelerated curing is often done using live steam or radiant heat from heaters attached to the form itself.
Double T's for parking garages really need to be held to a high standard. When they're assembled in a garage, they make the finished surface. There are tolerances for putting these pieces together, offsets in the surfaces. All of the connections are very sensitive as well. To be executed properly, the embedments in the double T have to be placed properly. So there, again, are a lot of critical issues that you have to be concerned with to get proper performance out of that simple double T.
After 12 to 16 hours of curing, the T's are ready to be stripped. The QC department first tests the concrete to be sure it has achieved the strength required to detension the strands, typically 3,500 psi. This is a typical test being conducted. The strands are detensioned in a specific sequence established by the QC department or the plant engineer. Here, personnel are positioned at each end of the bed and at some of the intermediate bulkhead locations. On a signal, they burn the strand at each end. After all the strands are cut and block-out formwork has been removed, the tees are stripped from the form. Cables are attached to the lifting devices, and each piece is removed and transported to a detailing area for any minor cosmetic touch-ups. Also at this time, the QC department does a post-pour QC check on each piece that is brought to the detailing area.
When I first get back there, I go and check the length of the piece and verify that within, there's a tolerance of probably a 1/4 inch or so. Check the width, we check the vectors, we check the electrical blockouts. I do a visual for any type of discoloration in the stems underneath the piece, any type of surface cracks, bug holes, just do a complete visual.
Any defects are noted so that repairs can be done before shipping the tee. After all the work is completed, the double tees are moved into the storage area where they are typically stacked using appropriate dunnage located near the ends. When the job site requires the tee to be shipped, it is loaded on a trailer and transported to the job site. What you have just observed is the process for making one type of pre-stressed product. These other types are made using essentially the same process. Hollow core plank, which are used for floor and roof components in multifamily housing, schools, hotels, and many other buildings. Inverted T-beams, which can be used in any total precast concrete build system. Columns, which are cast horizontally and then rotated in the air at the job site. They are often designed as pre-stressed components. Architectural spandrels used in office buildings and parking structures can be made using the pre-stressing process. Deck slabs and box beams, which are used primarily in short span bridge construction. Standard ash-toe girders, which are used in long span bridge construction. Standard bulb tees are also used in long span bridge construction. Pre-stressed piles that support any type of building in areas that have unfavorable soil conditions. As you can see, there are many types of pre-stressed products available. The variety of products that can be pre-stressed in a long line operation is almost unlimited and is up to the imagination of the design professional.
We really do encourage our customers and architects and engineers to get to our plants to really understand how precast concrete is made. They need an understanding of the high quality that they can get out of precast concrete as opposed to the random quality that you might get out of cast-in-place concrete.
Well, it's important that we do things as efficiently as we can and as cost-effectively as we can, but also as well as we can. And it's not only my responsibility, but the responsibility of everybody here, management, labor, everybody included, to do the best job that they can to, at the end of the day, make a little bit of money, but also have a customer that's very happy and will possibly want to have some return work coming back our way.